So on this page, we start to get into the factor and the remainder theorem. So this one says, which of the following is a factor of this cubic polynomial? Now, to figure out if it's a factor, I could try to factor this expression, and it's actually not factorable with grouping, which is the method we could try. The second idea is I could try polynomial long division and divide this by each of these. That would take a while, a little error prone. The fastest way to do this is to graph this cubic polynomial, so x cubed minus 10x squared plus 11x plus 70. And if any of these is a factor, that means in the table, the opposite value will be a root. So I'm going to check in my table for x plus 10, I'll check negative 10. X minus 2, I'll check 2, and then I'll also check a 7 for the third choice and a negative 5 for the fourth choice. So if I check these numbers, negative 10 is definitely not correct because its y value is negative 5,720. 2's y value is 60, 7's y value is 0, and negative 5's y value is negative 360. So it looks like this is the correct choice. So the idea is one of the factors of this function is x minus 7. So if I set this equal to 0 to solve it, I would get 7 as an answer, which is why the graph gives me 0. So that's choice 3. Just a step further, and I'm actually going to show both ways for this, the polynomial long division. I'm not going to bring up a calculator, but I'll talk about the calculator. So to find a remainder, I could do the polynomial long division. So I'm just going to set that up. Now, a lot of times on the Regents, they'll give you one that's really hard so that you do have to use the second method, which is the remainder theorem. So I'm going to say how many times does x go into x squared for this method. X times x is x squared, x to the first times x to the first. Then we're going to multiply this out. So we have x squared minus 2x. Distribute our negative. 8x plus 2x is 10x minus 7. How many times does x go into 10x? That's 10 times. So now I'm going to multiply this out. I get 10x minus 20. Distribute my negative sign, cancels. Negative 7 plus 20 is 13. So the correct answer is number 1. Now the fast way to do this is similar to the factor theorem from number 5. I can graph x squared plus 8x minus 7 in my calculator, and then check the table at positive 2 because we're dividing by negative 2. Now, if I do that and I graph this, my y value is 13. So without even doing the long division, just calculator work, you can get the remainder, and both would give you the same answer. So the last one, we're going to look at the graph of a cubic polynomial and also get into some factoring. There is more factoring in a different lesson or a different practice as well, a little bit more in the second one. So here's our cubic polynomial, x cubed, x cubed minus 5x squared minus 4x plus 20. And we're going to solve this algebraically or find the x-intercept. So I set it equal to 0. Now this has 4 terms, so if I have to solve it algebraically, I'm expecting to do factoring by grouping. So I group the first 2 together, take out the GCF, group the second 2 together, take out the GCF. Now the GCF of these 2 parts is x minus 5, so I take that out and I'm left with x squared minus 4. Now I can continue factoring the x squared minus 4, or I can use the fact that it's an incomplete quadratic. So here I can just say x squared equals positive 4, moving it over just like I did with the 5. When I take a square root, I just have to be careful and make sure I remember my plus or minus. So the roots of this, which I could also get graphically from the table, are 5, 2, and negative 2, but this problem said to solve it algebraically. So now we're going to describe why this can't be the graph. So I have 3 roots, but they're all single roots. So if I was graphing this function, first off, it's a positive x cubed. I know the shape of the graph would have to be something like this, where the 2 ends point in opposite directions, specifically the negative side goes to negative infinity and the positive side goes to positive infinity. This graph shows a double root, possibly, or we're not sure of the value because we don't have the scale, but we can tell it's around the negative 2 these could be feasibly 2 and 5, but we don't have a double root at -2. We have one root at -2, and this shows an x to the 4th graph. So basically, you could write a bunch of stuff. I'm going to write this is not the shape of an x cubed graph. You could write about the double root. There's a lot of different ways you could take that. The last problem on this page shows another identity. We had one of those on the first page. So basically, I have x cubed plus y cubed. This is actually one of our factoring rules. This is the sum of perfect cubes. We usually use an a and a b when we write the definition. So this shows my a plus b times a squared minus ab plus b squared. We do know that's the correct formula. We're going to prove it by simplifying. So this is x cubed minus x times negative xy is negative x squared y plus xy squared. So that's my first three distributions. And now I'm going to do these three. So I have plus x squared y minus xy squared plus y cubed. And that should all be equal to the x cubed plus y cubed. So the reason this works is because these two terms cancel and these two terms cancel. And that's why we have just x cubed plus y cubed equals x cubed plus y cubed. So there's a little proof. That's the justification. Remember, justifying means to show the math work. Explaining means to write a sentence.